This is example problem 8. So our previous two questions, we were looking for the components of forces that act along certain lines. And we ended up with a triangle. But if you stop and think about it, all those two previous cases are of the form of F at some angle is equal to A at some angle plus B at some angle. And so this is a picture of it. A at some angle alpha, B at some angle beta. So this is a B vector. And this guy plus this guy gives me F at some angle theta. So this vector equation can be written as two scalar equations. In the x direction, we can say F cosine theta is equal to A cosine alpha plus B cosine beta. In the vertical direction, we can have F sine theta is equal to A sine alpha plus B sine beta. If you look at this vector equation, there's 6 unknowns here. There's 3 magnitudes, F, A, and B, and 3 directions, theta, alpha, and beta. And I can write 2 scalar equations. To generalize this problem, if I give you any 4 of these pieces of information, you should be able to solve for the remaining 2 from these 2 scalar equations. Our previous 2 problems were kind of the same. F was completely given. You were given an angle, you're given a beta, and you're asked to find the magnitude of A, the magnitude of B, and it led to a pretty simple solution. But can I change that problem up a little bit? Can I give you a different combination of stuff and ask you to solve for something else? So let's try something a little harder. What if I give you F, A, and B, and give you theta, and ask you to find the angle alpha and the angle beta? So these are 2 unknowns, and I've got 2 equations I can write. So theoretically, I should be able to solve for 2 equations, 2 unknowns with 2 equations. Let's draw the picture. So if you draw the picture, I've got, and let's say that F is 100 pounds at 50 degrees. Let's say A is 60 at some alpha, and B is 50 at some beta. And I don't know what alpha and betas are, so I want to solve for those guys. So going straight to my 2 equations approach, in the x direction, I have 100 cosine 50 is the x component, and that's equal to 60 cosine alpha plus 50 cosine beta. In my vertical direction, I have 100 sine 50 is equal to 60 sine alpha plus 50 sine beta. And so this gives me 2 equations and 2 unknowns. However, this is not a linear system because these unknowns, alpha and beta, are within these cosine functions. I can't write a simple matrix solution of this guy. Fortunately, your calculator, the nSpire, lets you solve a system of nonlinear equations. And so what I'm going to do is I'm going to let alpha equal x and beta equal y, just to make it easier to enter. This 100 cosine 50 is 64.3. This 100 sine 50 is 76.6. And so what we're going to do is we're going to go on your nSpire. I'm going to go Menu, Algebra, solve system of equations. And you got a linear system of linear equations, which is your simult. Or you just have a system of equations which may or may not be linear. And so I'm going to solve system. I'm going to say enter. And then it says, how many equations are you trying to solve? And it's got a 2 there. And I'm going to go 2 equations. And my unknowns are x and y. And so it's really alpha and beta, but it's just easier to use x and y. And so then I'm going to go OK, and enter. So it gives me this setup. It says solve, and we're going to write an equation here, and I'm going to put an equation there, and we're solving for x and y. And so the equations I'm going to put in there is 64.28, 64.28 is equal to 60 times, to get cosine, I'm going to go trig, enter, x, and x is down here, plus 50 times cosine y. That's my first equation. Then I scroll down for the second equation, which is 76.6 is equal to 60 times trig sine x plus 50 times trig sine y. So those are my 2 equations. 64.28 is equal to 60 cosine x plus 50 cosine y. 76.6 is equal to 60 sine x plus 50 sine y. So this is 2 equations and 2 unknowns, but they're not linear. It's not a matrix solution. It's the calculator uses a numerical solution to get the answers. And so we're solving for x and y, and we just hit enter. And this is my result. I get x, which is alpha, is 72.33. Y, which is beta, which is 22.87. If you draw a picture of this is my original f. And my original f was 150 degrees. The 150 degrees. And I basically got a 60 and a 50. And this angle here is 72.33, this angle. If you stop and think about it for a while, and I did this back when I was cooking up these problems, you realize that there's actually another solution. This 60 can also be here plus 50 here. And I don't have time to go through this, but if you figure out these angles, this phi, so this is 50 degrees, and this is 72.3, so this phi is 72.33 minus 50, which is 22.33. And then you can solve for this guy, psi, which is 27.13. And so you can figure out that your other solution is these guys. And you can plug these angles into your, so if you go back to your original system of equations, which is these, and plug in this set of alpha and beta, will satisfy these 2 equations, and this set of alpha and beta will satisfy those equations. Technically, you can actually also use law of sines and cosines to solve this system too, but it gets a little tricky getting all the angles figured out. But again, I'm trying to build your skill level and learning how to use your calculator, but also thinking about how these problems work and different equations that you can write to solve these problems. And so I'm trying to expand your analytical toolkit with respect to vectors. So this is example problem 8.